morning, wherever you are and you're listening to, and people not only listening today, but also who'll be downloading the recorded version of this webinar on the shipmanagementinternational.com website, and that'll be available in the next week or so. But I'd like to welcome you all on behalf of Stream Marine Training and also Ship Management International. Our latest in our industry webinars, but looking at the very, very emotive and pressing challenges facing maritime operators to do with the safe carriage of electric vehicles at sea. And really, as EV numbers surge, so too does the complexity of managing the risks associated with transporting EV-powered vehicles. Regulations are still finding their footing, and the maritime industry is being asked to bridge that gap. So this webinar today will really talk about a number of issues, what companies are doing now while they wait for the IMO's updated regulations, and how can operators ensure that vessels, crews and procedures are aligned to where compliance is heading. We'll also be looking at the whole issue of training and preparedness as well. Just before I introduce the panelists, who've been sitting there very, very patiently, just to sort of direct the delegates who are coming in, you have down the bottom the sort of Q&A, question and answer, and also chat facility. Probably easier if you put it on any questions you have on the Q&A. We've got a couple of sections on slides here, one from Craig and one from John, and then we'll be talking with Stuart. But then really encourage you to send questions in through the Q&A, and I will do my best to put those in front of the panelists. So really, just to introduce the panelists, and starting bottom right on my screen, John Garner, who's owner of JG Maritime Solutions and Interferry chairman of Regulatory Committee and Regulatory Affairs Liaison. We also have Stuart Reid, who's superintendent at Serco Northlink Ferries, and Stuart will be giving us a little bit of a sort of perspective from the ferries side. And also we have Craig Smith, expert consultant and instructor at Stream Marine Technical. So really, just to sort of set the scene, but I am going to come on to John in a second, who's going to do really set it for us with his 10 to 15 minute presentation. But there is a growing challenge as far as all of this is concerned, because the maritime industry is at a pivotal point as EV carriage grows rapidly. But technologies are, advancing faster than regulation. And the challenge lies in bridging that gap through proactive compliance, operational readiness, and crew competency. John, you know a lot more about this than I do. May I pass the baton over to you and the microphone over to you? Could you just give us about 2 minutes, just introduction on yourself, who you are, and then go ahead with your presentation, and then I'll get Stuart and Craig to introduce themselves in a minute as well. But if you could just introduce yourself and then start with your slides, that'd be excellent.
Yes, thank you very much. So my name's John Garner. I've been running a maritime consultancy company for the last 7 years. And basically, I do quite a lot with Interferry, where I'm the regulatory committee chair. Previous to setting up my own business, I was 15 years as the fleet director for P&O Ferries, running ro-ro passenger ships, ro-ro cargo ships, container ships. And before that, I had 6 years in the MCA. So that's a little bit where the regulatory background comes from. I'm just going to.
Okay. Well, while you're doing that, I'm going to get Stuart and Craig to do their 2 minute introductions as well. So Stuart, could you just introduce yourself for 2 minutes, and then we'll go on with John's slides. I think that's a better way of doing it. If you could just quickly introduce yourself.
Yeah, thanks, Sean. My name is Stuart Reid, Marine Superintendent with Serco Northlink Ferries, based out of Aberdeen, heading to Orkney and Shetland. I've been with Northlink Ferries for 12.5 years now. First 11.5 was on board as a deck officer, working my way up from third officer, so I've got a lot of experience loading the vessels as well. I've been in the Marine Superintendent role for a year now. I also do a lot of work with the UK Chamber of Shipping. I'm the chairperson of their Vehicle Working Deck Safety Group. I also sit in their lithium-ion batteries panel as well as various other ones, and additional groups with the MCA and that, where we discuss electric vehicles as a whole. Thank you.
Brilliant. Thank you very much. And Craig, are you okay just to give us a 2-minute dialogue of yourself?
Yeah, thanks, Sean. Yeah, my name's Craig Smith. I'm one of the technical instructors here at Stream Marine Technical and Training. The basic functions we do here is IGF code, alternative fuels, technical consultancy for owners and vessels moving over onto these new types of fuels. And my background is an engineer for 15, 16 years, working on basically different types of tankers, multi-purpose offshore vessels, and then 5, 7 years as superintendent, vessel manager, again, working different types of tankers from oil tankers, LPG, through onto LNG vessels. 2 years now here at Stream Marine Technical.
Brilliant. Well, thank you very much, Steve Craig. John, I'm going to come back to you. Please, if you can maybe set the scene very much as far as, look at the regulatory side and what have you, but can I hand over the microphone to yourself?
Yes, thank you very much. So we're going to look at the challenges of carrying EV-powered battery vehicles on board ferries and car carriers. Specifically, the areas I'll cover is the regulatory landscape and compliance gaps, industry readiness and global adoption, and operator responsibility and enhanced measures. So just to set the scene quickly, over the years, maritime casualties have driven changes in regulations, and we can see a need for regulation now. Recent incidents, Grande America, Felicity Ace, Fremantle Highway, and more recently, Morning Midas. But as well as those vessels, this is the Herb Sharman, which was in a US port, had a fire situation. And with the focus of fire incidents, the USA became very concerned and raised this at IMO. And they raised it at a subcommittee meeting called Triple C number 8. That's carriage of cargoes and containers at IMO. And that's way back in 2021. And they suggested changes to various special provisions within the IMDG code to address the emerging issues that they saw. Let's fast forward to September 2025, whereby the US did step out of those subcommittee meetings, and it was taken over by another party. We've now got to a position where it's been recognized that ro-ro passenger ships are not the same as vehicle truck carriers, and therefore they've been taken out the scope of change of a special provision. This correspondence group has run sort of between the sessions and also in working groups at IMO, and it's particularly looked at the special provisions, and they've looked at how they should assess the safety condition of a vehicle prior to offering it for transport. And really, there is now obligations on the consignor to assess the safety condition of a vehicle prior to offering it for transport. Main concerns have been related to carriage of damaged vehicles and batteries can be subject to a special provision. You can see the detail there, which I'm not going to go through, but importantly, from a passenger ferry perspective, it's finally been recognised that ro-ro passenger vessels and the vehicles that are driven on by passengers are not the same as second-hand used cars being offered for carriage, often across oceans such as Atlantic and Pacific, whereas ro-ro passenger ships are normally short international voyages. So in 2021, there was a Chinese proposal to basically evaluate the fire protection, detection and extinguishing arrangements on board vehicle, special category and ro-ro spaces to look at reducing the risk of what they term new energy vehicles. So that was electric vehicles and alternative fuel vehicles. So really there's a timeline here. And the reason I put this up is just to demonstrate how long it can take at IMO from a proposal to get something into a work item to an actual entry into SOLAS full-bodied. And the timeline here is about 11 years. But importantly, the work is going on between time, and when something comes out, such as guidelines for the carriage of battery electric vehicles, which are now being proposed to come out of the correspondence group and will be put to the committee meeting SSE 12 in March 2026. 2026. And if they are agreed, it'll go through various stages. So by early 28, we could have the correspondence group finalising interim guidelines for further approval. But at least the guidelines would be available and to inform industry. Just looking back a little bit on the regulatory landscape, going back even further, 2016, there was a new output posed in the Ship Systems and Equipment Committee. And that was about SOLAS Chapter 2.2 associated codes to minimise the incidence and consequences of fires in ro-ro spaces and special category spaces of new and existing ro-ro passenger ships. That's new and existing RoPacs. And that went on from 2016 onwards. Importantly, in 2019, there was a EU project. It was called Lashfire for short, but you could see the full-blown title there: Legislative Assessment of Safety Hazards of Fire and Innovations in Rural Ship Environment. And there is a website that's still up and available. Once again, in 2019, the interim guidelines came out, so those were available to industry, and that was the MSC Circular 1615 came out in 2019. The Lashfire project ran between 2019 and 2023, seeking to inform further IMO deliberations, and it came to a resolution. MSC 550 was adopted in 2024, and that will be taken forward, and those new regulations will come into SOLAS for new ships 1st of January 2026, and for existing ships first survey after the 1st of January 2028. Again, it shows the long period of time, 10 years or so from inception to going into full-blown SOLAS, but we do have interim guidance along the way. It shouldn't have taken so long, but it did take a long time in that CCC subcommittee meeting to really explain and have understanding about the different ship types and how that affects the industry readiness and global adoption of various regulations. So we've got the ro-ro passenger ship, more than 12 passengers by definition, can have 1,000 to 4,000 lane meters, and passengers on the certificate from 36 to 3,000. We can have a ro-ro cargo ship, maximum 12 passengers, mainly lane meters, traditionally 1,000 to 6,000, and they're working in European short sea markets. And then you've got vehicle carriers, pure car and truck carriers, maximum 12 passengers, but up to 8,000 car equivalent units, and they can be quite often on long international trans-ocean voyages. Just to look at the scope then involved in that Lashfire project, system suppliers, Unifier and Vicare, you will recognise, research and development institutes, basically universities, RISE, the Fire Research University from Sweden, led the project. The authorities in the advisory group basically flagged states, and there was about 12 of them, plus EMSA, RENA and BV, regulatory bodies, Interferry and Sea Europe. And then on the operators advisory group, there was 10 different operators, and we later got insurers involved as well, third-party P&I insurers, and ship integrators were Stena Line, DFDS, others, two other companies. The scope of the project was very significant. These were the main areas of effective manual operations, an inherently safe vessel design, ignition prevention, detection, extinguishment, and containment, split into subcategories. So there was 20 different areas of project management that were going on. And within that, there was opportunities, and they actually set the SOLAS fire extinguishing and suppression arrangements in place and carried out full-scale fire tests. So the one on the left is an internal combustion engine vehicle, and that is at the most intense stage of the fire after about 3 minutes, 30 seconds. And that's compared to a BEV battery electric vehicle on the right-hand side, the most intense after 19 minutes. So why the difference? Well, here we have the recording of the heat release versus time. And if we look at the left-hand one first, the internal combustion, you can see that massive heat release after just a few minutes, that 3 minutes, 30 seconds, which is probably the fuel tank exploding and that massive sort of increase in heat. You can see with the 30 minutes where you have a water flow rate that the fire can be suppressed. And then, of course, there is always the chance of the fire becoming greater if the water extinguishment was not able to continue. On the right-hand side, on the battery electric vehicles, you see it at the different levels, but it's a slower gathering of heat intensity, getting to about 3,000 in total. And then you can see that the water flow rate does suppress and able to suppress the fire scenario, but there is always the danger of reignition, which has to be very carefully thought about. So that's the test rig you can see on the right-hand side. Because it was such a significant test carried out under controlled circumstances, Interferry put a paper to IMO where they are an NGO, non-government observer, and basically the findings of tests of a fixed water-based extinguishing system simulated on a ro-ro deck in relation to thermal runaway fire in a battery electric vehicle. The drencher system was capable of containing the fire, and the overall risk of carrying such vehicles could be considered equivalent or lower than carrying conventionally fueled vehicles, was their outcome. And just to give more context and information to industry, Interferry have done these flyers. There's lots of detail there, but on the right-hand side, but basically the outcome is there's no higher risk of fire from battery electric vehicles compared to any other vehicle on board, be it internal combustion vehicle or others. They are different, and the way that you would approach them or deal with them would need to be different as well. Let's just look at some of the enhanced measures that operators have been responsible in putting in place. Top left, as I look at it, shows you the position of a vehicle within a stow mix. There is options such as very large fire blankets, but they can be difficult to put on, particularly if there's a strong fire situation at hand. This was at a fire school, one of the partners in that project down at Gijón in Spain, where they actually set alight battery electric vehicles, and the firefighters and ship's crews taken there for this particular exercise tackled the fires. They also, within the project, developed these special lances. You can see it's a lance of about 1 meter in length, had 3 nozzles on, and then the far right is the version that's been matured from the work activity within the project, and some operators have considered those appropriate to deploy on board the ships so that they could be put either alongside a battery electrical vehicle on fire and potentially just underneath the bonnet compartment. Looking at basically the different systems we have today on board ro-ro passenger ferries. Existing systems, often standalone, not integrated, can lead to errors, very stressful circumstances. And the left-hand side is a picture of the drencher room on board Norman Atlantic, where unfortunately the incorrect valves were activated. That was simply through stress. The picture on the right-hand side shows a digital fire central development of an integrated system that can assist the operator when they're looking at fire management on board passenger ships in particular. This next slide shows the detection sort of options that we're taking within the project. Across the crossbar on the top right, there will be flame, heat, smoke, CCTV type detectors. And the bottom right is basically a lattice work type almost fiber optic cable that can be run in the deckhead and was trialed in real conditions on board a DFDS ship, the Hollandica Seaways, I think. And this not only gives the chance for a point load detection of a fire, but actually along the length of the cable, of the detector cable itself. Here we see fire monitors, which are to come in for ro-ro passenger vessels in the near future. On the top left, it's RISE in Sweden doing controlled trials. Top right is a picture of a Stena Line vessel that has actually fitted the fire monitors ahead of time. And the two lower pictures are pictures of fire monitors with foam applicators available. And they are operating on Dover Calais. They're the Sea France vessels that was, the Berlioz and Rodan. Today they're run by DFDS Seaways, but I believe those monitors have been on board, which basically cover the weather deck, dangerous goods area since those ships were built approximately 25 years ago. On the human element side, the HTW subcommittee has agreed gaps within the SOLAS code and convention, 416 in total, and they're currently going to address the deck department and engine department in the next session. But two of particular interest, 277 and 325, add requirements on the ability of seafarers on ro-ro passenger ships to cope with fires caused by new energy vehicles. And the second one, add a KUP. It's basically competence, understanding, proficiency for after firefighting involving dangerous goods. It may be added electric vehicles with lithium-ion batteries and batteries with similar risks. So further support through regulations will be coming. Just looking then at the challenge of carriage and ro-ro passenger ships on the left versus cargo ships, in particular truck carriers on the right. We can see through that MSC Circular 550, which will go into SOLAS, there is elements coming in for new and existing ships, fixed fire detection and fire alarms, video monitoring, structural fire protection, fixed water extinguishing systems through the fire monitors. And they'll come there. And on the right-hand side, there's very little in that same SOLAS Chapter 2.2 Regulation 20 about cargo ships. There is 4.1.5 about fire detection and fire alarm, but the other aspects are not applicable at the moment. So what can be done for cargo ships? There are potentially the interim guidelines to come out mid-2028. Class societies are bringing about notations for battery electric vehicles. And there is these two publications I've shown you there, fire response high-level guidelines from the International Chamber of Shipping and the International Group P&I Clubs, and safe carriage of EVs from the Maritime Technologies Forum, which particularly targets car carriers and truck carriers in advance of regulations coming. So to sum it all up, what do we need to do to rise to the challenges? Effective manual operations such as fire patrols, realistic drills, new manual equipment. Prevention can be done by screening and management of fire hazards, refuse damaged cars. Detection, early detection in open, closed and weather decks, use of modern technologies for detection and localization and confirmation of the fire. Extinguishment, early use of a fixed water-based system to suppress the fire before they take hold. And it's recommended 10 to 12 minutes is the maximum that can be allowed before a fixed fire extinguishing system is introduced. And to enable that, potential early installation of the fire monitors I showed you, and what about retrofit of water-based systems for car carriers? On containment, there is the opportunity for the smart use of roller deck ventilation to extract smoke in early stages of fires, but it must be done by well-drilled crews and potential vertical water curtains. So, in summary, I'd say well-trained, familiarized drill crews with knowledge of EV-specific hazards, firefighting management techniques, supported by risk assessment, training plans, and proactive safety management, who anticipate emerging compliance standards will be able to meet the challenges of carrying battery electric vehicles on board. And the watchword is, if we work proactively together as a team on board, we can ensure that everybody goes home safely.
John, thank you very, very much for that. And just really little note to the delegates, please, any questions you have, just put them in the Q&A. The interesting thing, I suppose the obvious question is, what's stopping an accident now, John? I mean, it's guidelines, keep an eye out for this, whatever. But is the industry ready for this? Is it implementing all of these aspects that you're talking about? Because accidents can happen before mandatory regulations come into force. What are your thoughts?
Yeah, I mean, my thoughts are that the proactiveness of the industry, which goes back to 2016, 2019, with those shipping companies, the FDS, Stena Line, and all the 10 in the advisory group, CalMac Ferries, and others, were concerned enough to get involved. They then had the benefit of the Lash Fire project, which was a really comprehensive and integrated project where the benefits of early detection and localization of fires and then early use of fixed extinguishing systems was brought to bear. And the insurers will tell you, we'd really like to they will recommend a fixed extinguishing system being used after 10 minutes, 10 to 12 minutes. And crews have got to be really well drilled to be able to achieve that. But if you do that, the suppression of the fixed extinguishing systems have been shown in the additional tests carried out that they will suppress such fires.
Stuart, can I just bring you in before we then go on to Craig and to listen to his presentation? From what John is saying there, are any of those aspects that are sort of concerning to you as an operator? And how can you ensure that your vessel's crews and procedures are aligned to where compliance is heading? I mean, what's your response to John's presentation there?
I think one of the most interesting parts of John's presentation there was interim guidelines can still be 2.5 years away from being published with it. So I think the time being, operators working together through groups at the Chamber of Shipping, UK Chamber of Shipping, other projects with EVs, and sharing what procedures we're doing, what practice we've found, and any incidents we've had, and aligning our procedures as quick as we can, sharing ideas and improving what we can is our best option, and continuing to push MCA classification that to provide more guidance as well, and training through operators such as Stream Marine or other ones. Yeah, that's my main takeaway.
Serco, Northlink, Ferries. I mean, what are you doing to mitigate against such fires, BEV fires, and what have you? What procedures do you have in place?
Okay, we've taken over the last few years a number of procedures onto our vessels and through the booking process and shoreside and trying to mitigate the risks. For people who don't know Northlink Ferries, I'll just give a brief overview. We run 3 passenger ships and 2 freight ships over the north of Scotland. The 3 passenger ships can take up to about 100, 105 vehicles or a combination of vehicles and trailers. And the 2 freight boats can carry up to 12 passengers, which is predominantly trailers we take. With that, so our procedures that we've got, we feel are pretty good for ours, but due to the variety of different routes that rural ferries can go on and car deck operations might not be perfect for yourselves. But when it comes to our procedures, it starts as soon as a passenger tries to make a booking. They go to put in the vehicle details. We now ask as well what type of vehicle it is, whether it's a hybrid, a regular car, an electric vehicle, whatever there. And if it's marked down as a hybrid or an electric vehicle, parts of our condition of carriage is that the vehicle has to not have sustained any damage to the batteries, so it has to be cleared there, and we would look into it further. So it has to be in good condition health. When the vehicle comes to check in to travel, provided that it's still not had any damage, that will be confirmed with them and in good working order and no warning lights or faults are showing on the dashboard or anything. We then identify it with a windshield hanger with a green banner on it. So that identifies the ship's crew that it's either an electric vehicle or a hybrid vehicle. We don't differentiate them regardless if it's full EV or a hybrid. We'll just classify them together. So the loading officers, they'll be aware of them when they come on board. They're then able to mark them on their loading plan. We don't have a separate section of the vessels for the EVs. We just keep a note of where they are. So if there was an emergency situation, we'd easily be able to consult the plans, similar to like where you have your DG plans and that for where dangerous goods are. We've got marks for the EVs there. We've invested in a number of equipment and procedures and training presentations. Our senior officers, chief officers and masters, and now chief engineers and second engineers, we send on specialist EV training courses throughout the year when it's available to give them a broader understanding of electric vehicles as a whole, recent incidents and procedures as well. We've also got an EV trading presentation, part of our familiarisation process for new crew for them to watch, that just covers our procedures and what EVs are and industry regulations. We review that every year. It's coming up soon for a new review, and then any new information or feedback we receive from officers that have been on these training courses, discussion with them, we can add into it and make changes as required, as well as our yearly reviews on our risk assessments for carriage of electric vehicles. On passage, we've got thermal imaging handheld cameras. Our deck crews go and do rounds every hours of the car deck. So part of our procedures are they take that and they can monitor the temperatures of electric vehicles. And if we're noticing a steady increase throughout the passage, that can be an early warning sign. Some of the feedback we've been receiving lately from the EV courses is that there's a release of noxious gases happening and are more detectable quicker than when the temperature rises through it for the thermal imaging. So we might look into the future of having our crews actually carry gas detectors and go near the vehicle. And if they alarm, that can be even an earlier warning sign than the thermal imaging cameras. We've got a number of equipment when it comes to actually dealing with an EV fire. Our primary view when it comes to it is containment. So if we did notice that the noxious gases were coming off or the temperatures were rising, we've got 2 fire blankets designed for vehicles, one at each end of the car deck that the crew can quickly deploy. We'd wait, depending on the release of noxious gases, you might want to have the teams full in the EV for that. It's just got 2 toggles on it. You just can lift it right over the vehicle and put it down in the sides there. So that would be that there. But if it was in a fire situation or close to ignition, that'd be too difficult or too dangerous to go for that at the time without a full suit. And then the dynamic risk assessment would be taken there for that. We've also got in our procedures that if there's a fire on a regular vehicle, non-electric, but there is EVs in the area nearby, we can then utilize these fire blankets over the vehicles nearby firewood to try and prevent the heat and the ignition of these vehicles. We've also developed under vehicle lance on board, similar to the ones that John showed in some of the pictures. I don't have many slides, but I do have one here showing it that I can just share my screen to show it there. Can you see that there, Sean?
Oh yeah, yeah,
Yeah. So this is just showing it during a training exercise. So if you imagine the wood there is the underside of a car, it's an under vehicle lance just hooked up to a regular fire hose. It goes underneath, and there's 3 prongs that come out the side, and it will just propel water up towards the battery compartment. The theory behind it, luckily, we've never had to actually deploy in anger. Whereas if you were suspecting there might be thermal runaway in an electric vehicle, there is you'd have the fire blanket over the top of it, the EV lance underneath it, and then that would hopefully provide cooling and containment until the ship could get to port with it. Stop sharing that. Now, precautions we've done is we've upgraded all our fire suits to a higher rating on board to deal with electric vehicles. We've got procedures in place for if there is an electric vehicle fire, the toxic chemicals that can come off from it can contaminate the fire suits. So when it comes to if there was an electric vehicle fire, the crews when they're coming out of there, anyone that was helping them get out of the fire suits and that should have appropriate PPE on, possibly using chemical suits depending on the situation, and make sure the stuff is bagged up and not touched with unprotected hands until it's been specialist cleaning the shore. When it comes to fighting an EV fire, as John alluded to with the fixed fire suppression system, all our underdeck ships have drencher systems. So that would be the first instance there. Would we be getting the drenchers straight on with it? And then ideally, if it's safe to get under vehicle lance on it, we'll get it underneath. Otherwise, we'll get 2 jet stream hoses on it, just cooling it as much as possible. Try and keeping it in one place and stop it spreading to other vehicles in the area until we can get to a port of refuge. Also, because of the intense heat at the bottom of the car, boundary cooling and monitoring the temperatures of underneath the decks below it, making sure that it's not going to spread downwards. We've got a separate checklist for a fire at sea. We've got one for fire on the vehicle deck, but we've got an additional one for if electric vehicles involved used in conjunctions with assistance from the masters. Obviously, during containment, you're going to be using copious amounts of water to try and stop it for a prolonged period of time to get the fire beaten down. So stability considerations and the runoff of water on the car deck has to be taken into consideration as well. When it comes to the actual shipping of EVs, we insist in our conditions of carriage that they have to have suffer no damage. If we suspect there is damage, we've been in contact with local specialist EV garages near each of our main ports, and we'd be able to send the vehicles there for an assessment to be done on them to confirm that they were, to the best of their knowledge, safe to travel. We do serve a lot of island communities, and what we have noticed is that a lot of the islands don't actually have EV manufacturers, car garages, or details there where they can actually go and get services repairs done on them. So they rely on shipping to the mainland. And we do get occasionally requests from passengers, their car needs to go down for a service, or that's been like this. Here, the situation arise. So we can look at that on a case by case basis. But there's the worry that either they don't want to tell us because they need to get it down south to the mainland to get it on, or from what we have seen with previous cases with electric vehicles, when you see it in training or in the news, that a car can have a slight bump in a car park on the rear bumper of that, and it can damage the batteries inside, and then hours, days later, that can lead to thermal runaway. So somebody could just have an innocuous bump that they don't think is nothing. No, I just hit a bollard at Tesco's lightly, not realizing it, not declaring it, but there has actually been internal damage. We did have one case last summer where there was a EV that had been in a serious car crash up on an island, and it was damaged with it, and it was a request to ship south, and we worked with the insurers, and I'm sure a lot of people have probably seen them in the news or in training courses, the big containers, the open top that the vehicles are able to go inside, and it can be flooded with water if it was to reignite. One of them was hired by the insurers. It was placed in the top deck of a freight boat, so an open deck there, monitored on the way south with it. But that was a specialist case there, coming directly from the insurers that we worked with them, and they were able to hire that unit. It's not something we've got available. Other than regular electric vehicles, another area of concern that we've got that we're looking
If I
to
can give you
strengthen.
2 more minutes, Stuart, because I need to bring Craig in a second.
Yeah, this is the last bit,
Yeah.
Sean, next is light electric vehicles such as your e-bikes and e-scooters. When
Yeah.
it comes to charging them, we don't allow them to be charged on board, same as we don't have any charging facilities for regular electric vehicles. However, we do find that some people, through either not knowing or trying to circumvent it, will try and take the batteries up the stairs from the vehicle deck to try and charge it in their cabins, which is a big concern. We don't allow it. We'll need to look at strengthening more to make people more aware of that. Our deck crews themselves are very good at identifying people and telling them, sorry, these can't go up and charge, but you always do worry that people might put them in their backpack as well.
Yeah.
Because when you think about a regular electric vehicle or a hybrid with these manufacturers, it is to a high standard of safety specifications that they are being made. So you've got to hope that the risk of it igniting is low. But if you buy an electric bike or an electric scooter with a certain rating on battery, there's nothing to stop that person going online to a third-party reseller, buying a unregulated battery that's more powerful because they want it in there, and you don't know how that's been tested, how that's going to work with the equipment. So I think, and I believe that when you look at the fire services report, they're getting almost one call every 2 days. I think it is in relation to an e-bike or e-scooter fire, particularly in London and that as well as other areas. I know a lot of trains have banned the carriage of them, so I can see that's probably where the next set of concern will be coming into, and we'll be looking to look at procedures for that. I think that's all then. I know you're worried about time, Sean, but if you get any specific questions you want to ask me, I'm happy to answer.
No, thank you very much, Stuart. That's a very good rundown on the procedures you put into place, and very interesting about the scooters as well there. Craig, thank you for waiting very patiently as well. So, because I know you want to talk a little bit about the practicalities of it and the some of the accidents that's happened and what can be done to prevent it and how crews can be trained. Can I hand over to you? Please feel free to, that's it, use the sharing capability.
Can you see it okay there, Sean?
Yeah, all good, all good.
Okay. Yeah, thank you very much. A lot of what I've got for just now has already been covered by John and Stuart, but it does bear repeating because of the significance that we have. Of course, there has been, as John said as well, incidents over the years. We've got Sincerity Ace, Felicity Ace, Fremantle Highway, and most recently the Morning Midas. These have led to fatalities on board, people disembarking from the vessel under emergency conditions. There has been fatalities, and of course we have had loss of assets as well. Investigations into these, they can differ at times. People say they all started with EVs. It's not always the case, but what is perfectly clear is if it does start elsewhere, if it gets to the electric vehicles, that is when things escalate and it becomes much harder to deal with on board, as already been said. The incidents, of course, that highlights the urgent need for improved regulations on detection, crew training and coordinated safety measures across maritime automotive sectors. Current status, as John's already said, there's no dedicated international regulations so far for the safe carriage of electric vehicles, battery hybrids, anything at sea. And I already said as well, with IMO roadmap, we should see something coming through 2027, 2028 with the interim guidelines, leading forward to implementation fully all the way through IMO, SOLAS, etc. Hopefully, we will be in a better position in a few years' time. Important for crew to understand, operators to understand, owners to understand, is the process of thermal runaway. And of course, thermal runaway itself, it is a self-sustaining exothermic reaction. It gives off a lot of heat and a lot of energy, and that is from within the lithium-ion batteries themselves. That does lead to the fire, the explosion, and toxic gas release. The thermal runaway comes from internal cell defects. It can be a manufacturing fault with the battery system itself. A cell can go into an overheated state. It spreads the heat across the rest of the cells, and that then just leads to thermal runaway across the battery pack. Outside of internal faults, electrical abuse, battery abuse, a crash, hitting a speed bump, anything bad like that can set off a thermal runaway shortly after the incident, or as already said, it can happen a few days later. Thermal runaway, it does lead to rapid heat build-up, emissions of flammable and toxic gases, and therefore after we have a fire with a high chance of reignition. Sometimes that reignition is hours or days after appearing, after you think it's extinguished. Detection challenges. The fires themselves often start deep in cargo decks or within battery packs. The limited visibility and delayed alarms, not always straight away possible to see it, even though you've got something taking place within inside the battery itself. Lack of integrated EV battery monitoring systems on board. Hopefully in the future, there might be something coming through where we can link up the cars, be it through a remote device, if the car's battery is warming up, starting to heat up, an alarm can be set off in the ship's automation system, and it's a good indication then that something might take place. Early detection is critical to prevent the escalation. The electric fires, they require prolonged cooling, sometimes hours and days. That is for the containment and suppression to try and stop the spread and save the vessels, save the assets. Water must be used in balance. We need to make sure the ship's stability is safe, containment safe. We understand, of course, that a lot of water can be applied to these batteries to extinguish them and keep them under control. There's thoughts in the future that fitting drainage pumps to each deck to take care of the water runoff, and that would hopefully save the ship's stability. Foam systems, fixed foam systems, they can be ineffective due to gas buildup, due to the energy that's coming out from the battery. It can disturb the foam and therefore make it ineffective itself. The toxic gases, the explosive gases, when a battery goes into thermal runaway, one of the first indicators will be like a vapor cloud coming from the vehicle itself. You can start off with a white vapor cloud, which is all the electrolyte in the battery exposing out, and then you can get the darker color, more black grey color, where that's the heavy materials coming out as well. The gases lead to hydrogen fluoride, carbon monoxide, benzene. These, for example, they can be released during a thermal runaway. The gases, they are heavier than air, and they can accumulate in enclosed spaces. It does require enhanced ventilation and gas detection systems. And as Stuart said as well, when we get to the training side of things, crew have to understand the need and the special protections required for decontamination of firefighting equipment, your fire suits, BA sets, even just your normal tools for fighting fires, all needs to be specially decontaminated afterwards because of these toxic gases. Level 2 fire suits, a good step moving forward would be to get on board vessels level 2 fire suits. They're a heavy duty suit and it helps prevent toxins getting through into contact with personnel. We know training needs to be improved. There are STCW gaps for specific fires such as EVs, lithium ions. That should hopefully get covered when the updates come through in the future. We need to understand the importance of manual firefighting skills in obstructed decks and environments. A lot of car carriers, they've got the cars strapped down on the deck, so you've got tripping hazards, you've got things getting in the way. We need to understand how we can fight fires in these spaces. Scenario-based drills, reignition protocols are essential, and the drill should be carried out as realistic as possible as part of the drill matrix on board the vessels. We know the vessels pack the cars in quite tightly, so we have to prevent the spread as much as possible. Fire spread, of course, will lead to such a big increase in the incident and make it even harder to take control of. Barriers, need to prevent protection barriers, spacing, deck ventilation, all these things put together can help limit the propagation of the incident. Fire blankets or water walls may assist in isolating affected vehicles. As I said, you can cover the car with the fire blankets. Even if you cannot get to the car itself, putting it on sidecars, that can also help prevent the spread to those cars themselves. Water walls, side blankets, side curtains, whatever you want to call them, placing them up between electric vehicles, all ready for the voyage. Quick activation helps prevent the spread as well. Crew inspections, yeah. Crew should be inspecting the vehicle decks, using thermal imaging cameras. They need to be trained in how to use them. They're simple enough, but yeah, need to be trained and ideally using them on the rounds within no more than 1 hour. Visual checks for smoke, heat distortion, noises from underside of the vehicles. The signs and symptoms of thermal runaway. One of the first signs will be noises from under the car. You can hear hissing, you can hear like popcorn noises coming from the underside of the car. So crew need to understand the characteristics of what a thermal runaway is and the signs and symptoms that come from it. Early intervention, of course, is going to be critical to prevent full thermal runaway events, if possible. Also, just to help prevent the spread of the fire. Stop the spread, yeah, as we said, tight storage on vehicle decks. The fires, they release intense heat and flammable gases. To help prevent, fire blankets, cooling systems, water curtains, and structural upgrades. Fires underneath, or fires on one deck can spread to fire above or below. Moving forward in the future, our vessel is going to have to be equipped with higher insulation standards going from deck to deck to stop the spread going up and again or down and losing the asset. Also the containment, if things do get beyond the control of the ship's crew and they have to disembark, do they have to look at different disembarkation systems, sprinkler systems to get to lifeboats, marine evacuation systems, anything like that. Manual firefighting where possible. Equipment on board will start with thermal imaging cameras to detect any incident starting. Water mists, lances, portable cooling devices. All these things should be deployed as early as possible. Of course, it does put the crew at a higher risk when they get into confined spaces, and that also comes down to drills on board and confidence in the crew. Need for proper equipment placement. If we've got decks with vehicles on one deck, which are EVs, have the equipment ready to deploy or even partially deployed in advance. Drainage systems are critical to avoid flooding, and we need to have the crew trained in rapid response and the protocols as well. We do know STCW just now does not cover thermal runaway, reignition risks, or the release of the harmful toxic gases. That needs to come through, and part of the courses that we do does cover these. The electric cars, they do behave different from your normal internal combustion engines. The way the flames come out from underneath, they can be jet-like flames, a lot of intensity behind them, and that is one of the reasons why we help get the spread of the fire. Crew, they should be trained to understand the characteristics of these types of fires, detect the early warning signs, and that is using the thermal imaging, listening out for the noises, looking for any signs of the flames, anything coming through. Respond safely and effectively, and use specialised equipment confidently. The equipment on board, firefighting equipment for manual intervention, crew should be trained with it, properly using it, and ready to use it in a confident manner. Regular drills should take place with all your water lances, side curtains, the thermal imaging, EV blankets and containment pods, long duration breathing apparatus if they have them on board. As Stuart said, got the blankets, got the equipment on board, get them used, get them training, have training kits on board in case they get damaged, simulate it the best way they can without actually having to set any fires themselves. The equipment strategically placed and clearly marked, routinely inspected and tested. The drills should simulate electric vehicle fires in various deck locations, practice boundary cooling and isolation, include reignition monitoring protocols, because as we know, we've said, reignition can take place hours after, days after. Has to be monitored even though you think you've got on top of the situation. Clear and communication. Who's doing what tasks? Commanding control, starting from the top, starting from the master. What's the plan and how are we going to tackle the situation? Updated SMS, as Stuart referred to, risk assessments, identifying the vehicles, what to do in the event of a fire, what equipment you have on board. And as we said, the International Maritime Organization, they are developing mandatory rules for the safe carriage of EVs or new energy vehicles at sea. They will be looking lithium-ion battery fire safety, the crew training and the gaps within the STCW, fire detection, suppression and evacuation protocols. We do need the manufacturers to step up, the car manufacturers to step up as well. The battery management systems will give an alarm on the dashboard of some kind to let you know there's a fault with the battery system. That doesn't help us if the ship's at sea and there's no warning, no external warning from the car. So the manufacturers hopefully will be able to in the future put audible alerts, the car horns or some kind of siren coming off the car, flashing lights, and as I said, wireless notifications sometimes could go through to a ship's system to help indicate as well when something might be going wrong. That all helps the crew on board detect overheating or thermal runaway before ignition. In Extreme Marine Technical, we have developed a course and we've put it in practice with a few companies already. Our main agenda for the course, the main covers descriptions of electric vehicles or hybrids, design layout of battery banks on vehicles, thermal runaway, fire equipment, the pros and cons of firefighting equipment. There is no ideal silver bullet at the minute to help take care of it very quickly. There's a lot of equipment out there on the market, not practical for vehicles, vehicle carriers of any kind. You don't have the space to use them, you don't have the training to use them, and they also put the crew at a very high risk getting right close. Some of them are battery penetrating devices, which flood the battery full of water, and that helps extinguish it very quickly. But is there a risk to the crew to use them? There has been vehicle manufacturers, Renault, for example, worked with a firefighting service for up to 10 years, and they've got a water injection port on their batteries to help take care of any fire incidents. A lot of cars now also have QR code on the dashboard. Firefighters, they can scan the QR code and it brings up a lot of information on how to deal with fires on board. There are case studies, of course, we go through and best practices that we know of at the minute, going from all the current information. Class societies, DNV, ABS, they've got a lot of good information out there as well, and they're good reference points. And of course, if anyone needs any help, any training, get in touch with us. We'll be more than happy to help.
Thank you very much, Craig. Thank you. Really comprehensive roundup, and actually filled in a lot of the sort of gaps that John and Stuart were talking about as well, and complemented what they were saying. Just really one question, and it is when you look at the damage that fire will do to the vessels, and we saw the 4 examples that excuse me, yourself and John put up on the screen. I mean, the fire damage is extensive. I mean, it is unrelenting. Do you think, Craig, that the industry is ready for all of this? Is it doing enough at the moment?
I think they're doing the best they can with information they have to hand. A lot of the companies have been, shall we say, the forward thinkers, as it's going back a few years now, purchasing a lot of equipment to do the best they can for the crew, while they wait for these regulations to come in place. When the regulations come in place in the future, key point will be, how does it affect new builds, and how does it affect current vessels? What retrofits do they have to do, and what's it going to cost? Of course, there should be no price on safety, but it's going to be a massive investment from the companies to get the ships up to standard.
Yeah, and I think that's right, and getting the whole industry working together on it, so you haven't got any fragmentation going on. I think the interesting thing that Stuart was saying there about, when an older car coming on board, and then you sort of take it to the local garage to see if it's fit to be transported. That sort of de-automates the whole system, really. And I think the industry needs to be aware that if these types of fires mustn't happen, and everything must happen automatically to ensure that safety is guaranteed with these vehicles. Thank you very much, gentlemen, for that. I mean, just looking at the participants here, you've been very quiet in your obviously listening intently, and that's great. Just to say that today's webinar will be edited slightly, and then it will be placed on the shipmanagementinternational.com website, and also pushed out on social media as well. So you will be able to get your colleagues to listen to it as well, and to access the information. But a lot of very, very valuable points raised there, really, and I mean this is a big issue. Demand for electric vehicles is increasing. We know that, but there are a lot of challenges there, and I think, and I'd like to thank the panel today for really putting everything into sharp perspective. To John, Stuart, and Craig, thank you very much indeed for your time today. Do appreciate it. And to the delegates as well, thank you very much. And as I said, we will be sending out the edited version of the webinar as well. So so the broader reach of SMI and the industry can also access it as well. But thank you very much indeed, gentlemen. I do appreciate your time today. It was excellent, good stuff. So thank you very much.
Thank you.
Thank you.